6.2 Binomial Probability Distribution. All right, so binomial probability distribution is a discrete probability distribution that describes probabilities in which there are two mutually exclusive outcomes. Okay? Typically, we refer to these outcomes as success and failure, so such as making a free throw and missing a free throw, getting a heads or not getting a heads when we flip a coin on those types of things, pieces. Okay, and so we have two outcomes, success and failure, for those pieces. Okay, so for our binomial experiment, we have a fixed number of trials. We call it our fixed number of times we do something, which is called a trial. All the trials are independent, so these things must happen. There are two outcomes, success and failure, and the probability of success is fixed for each trial of the experiment, so things can't be changing. Right? And so we call the x there the binomial random variable if we have a binomial experiment. Okay. So some notation: N represents the number of trials, P is the probability of success, and 1 minus P is the probability of failure. X is the number of successes, and those have to be between 0 and n. Okay, so first we need to just be able to determine if they are binomial experiments. All right, so the first one here, we have a basketball player who makes 80% of his free throws, and he's asked to shoot 3 free throws. The number of free throws made is recorded. So this is a binomial because there are 3 trials. We know it's a fixed number of trials. They are independent. Every shot is different from the other. And there are 2 possible outcomes, make or miss. Okay, the probability of success is 0.8, and the probability of failure is 0.2. Okay, so that one is binomial. All right, here we have a poll. 28% of Americans state that chocolate is their favorite ice cream. And so we have a sample size of 10 and want to know if they choose chocolate as their favorite ice cream. So this one is a binomial. There are 10 trials, so that's fixed. They're all independent because we're just asking random people. And there are 2 outcomes, whether chocolate is their favorite or not. So yes or no on chocolate. Okay, and then it talks about our probability of success for those. All right, and then the last one here, probability in which 3 cards are drawn from a deck without replacement. This is not binomial. Okay, so even though we're pulling 3 cards, when we take the first card out, that affects what the next cards can be because they can't be that first card since we're not putting it back in the deck. And therefore, it changes my probability each time with those. It's not fixed. Okay, so therefore, it's not a binomial. So if it's not independent and not fixed on those pieces, it's not binomial. Now, just a note, the word success does not mean positive. Something happens. Our success could be misses, not getting something, things like that for those. It just means it's the outcome that we want is what we consider a success on those. All right, so let's start computing probabilities here for these. All right, so we have 7% of the people have blood type O negative. And we're doing a simple random sample of 4 with those. Construct a probability distribution for these. Okay. All right, so first they go through and construct a tree diagram looking at S for success, F for failure on those. Okay, and we look at the outcomes. And so here we have all of those possible outcomes, successes and failures, when we're selecting people that are type O negative. Okay. All right, so now we want to look at each possibility for those. So what is the probability that we get none when we select our 4 people for this piece? Okay, and so they go through and look at the failures instead of successes on those because we don't want any successes, we want all failures for those pieces. Okay, and so they come up with these. Now, there is an easier way of doing this using the calculator. Okay, And so I'm going to show you how to do it here on the 84, and then I'm going to write out for those people that have an 83 what you need to do. It's going to look similar at the end, but the process in the middle may look a little different, okay? So first thing, we're going to turn our calculator on here for these, okay? And so when it's an equals, all right, so when we have an exact amount with these, so let me write that down up here for these. If we have P of X, okay, just a number for these, all right, we need to do certain things. So we're going to hit second and then this vars button right over here because we want to do a distribution, okay? And we're going to go all the way down till we find binomial PDF, okay? All right, so we're going to do here binom PDF, okay? Now on the 84, we can just select this and it's going to have us put in some things, okay? Now it has the number of trials. Now our number of trials was 4. Now our success, if we go back and look here, the probability of success was 7%. So that's going to be 0.07. That's success. And we're looking for 0 because that's what we're doing here, right? So it's P of 0. And we're going to paste. Okay, so it writes it out here on those. Now, for those people that have the 83, you're going to have to type this stuff in. It's going to open the parentheses, and you're just going to have to type that in directly. So it's always going to be what our N is for the number of trials. Then it's going to have your P, your probability of success, and then it's going to have your X value here, whatever it is, okay, for those pieces. So make sure that you put those in there correctly, all right? And then we press enter, and it gets the same answer that they have there, 0.74805 when we're looking at that, okay? And so that's going to be if it equals for them, all right? Now, what if we want to do another number? So say we're doing the exact same problem. I'm just going to hit second enter to repeat it and then change my 0 there over to a 1, okay? And we come up with the same answer that they got, okay? Now, let's go back to the original process, though. I'm going to clean this up here for mine. So I'm going to hit second vars, so second vars, and we're going to go down to binomial PDF, and press enter. Now again, if you have an 83 at this point, you're going to type in the N, comma, P, comma, X. For mine, I just need to fill them in. My trials was 4. My P was 0.07 for 7. And now I need to change that to 1. So now we should all look the same when we type that in. And we press enter. And again, we can see what we have here. Okay? And so then if we needed to do 2, we would go back and change the 1 to a 2 and get our answer. The same thing for 3 and 4 on those pieces. And then we could create our table if we needed to based on whatever the instructions ask us to do there for those. Okay? And so that's how we want to be able to find those probabilities for our distribution. Okay? All right, now here's the official formula for those pieces, but again, we want to use that calculator and let it work for us, okay? Now, other things that we have to look for are words. We're not always going to use equals. Sometimes we will. If it says exactly or equals or is, we're going to use the equals. But sometimes we're going to be using greater than or less than and all of those things, so we have to know those words and what they mean. All right, so let's look here at this one. It says that 72% of all adults would rather give up chocolate than their cell phone. In a sample of 10 adults, what is the probability that, and we're going to answer some questions here. The first one is exactly 8 would rather give up chocolate. So that's exactly 8. So that means that we're going to do the PDF. That is equals. okay, for that one. So let's clear that. So we're going to do second vars. We're going to go down to binomial PDF. This time our trials is 10. Our probability is 0.72. And then we are looking for 8. Okay. And then we press enter. And we see that we get 0.254 if we rounded 8 on those. Okay. Because it's exactly 8 on those. So if they say exactly, that's an equals for them. All right. Now, what about fewer than 3? Okay, so fewer than 3 means that we want that they can be 0, 1, 2, but not 3 or bigger. Okay, so less than, strictly less than, so 0, 1, or 2. We don't want 3 or bigger for those. Okay, so this is how they would do those. Now we could do the individuals 0, 1, and 2 and add those things together, much like they did here using the calculator. But there is another function in there. Okay, and so that function is strictly a less than. So if our p of x is less than or equal to an x, okay, so a value with those, all right, we're going to go back in, but this time we're going to do binomial CDF, okay, with those. And then it's going to open parentheses and we're going to put in N, P, and X. All right, so let's look at that here for these. All right, so again, let me clear that. So second vars. If we go just a little bit further this time, we see here CDF, okay, for them. And that's on part B there with them. We're going to select that one. So here we're going to do the number of trials. Now, our number of trials is still 10. Our probability of success is still 0.72 for 72%. Now, this time our x value. Now, you'll see that they have x less than 3, but my formula has less than or equal to. So that means that we got to go down 1 from the 3 to 2 because we're doing 0, 1, and 2 for those. And we're going to paste there and press enter. Now, when we look at that, mine says 9.6, but notice over here it says e to the negative 4. So what that means is we got to move this back 4 places, and that would give us the same answer that we have there on the computer screen of 0.0096. So it does give us the same answer when we are looking at this, okay? So be aware of those pieces when you're doing those, okay? All right. Now, what if we have at least 3? So it means 3 or greater, okay? So when we're doing that, 3 or greater, our calculator only does less than or equal to. It doesn't do greater than or equal to. But we can do the complement. And so that is 1 minus x less than 3, okay? And so we already know that. We've done the x less than 3 in the very last problem. So we do 1 minus that number for those, okay? Now, again, we could do that in the calculator here. We could do 1 minus second vars. We're going to go down to our CDF. We had 10, negative 0.72. Now, again, we do 2 because it's less than or equal to. So we have to be 1 less than 3. And we paste and press enter. And we still get the same answer that they have on their screen, okay, for those. All right, now how about here? Who would rather give up chocolate is between 5 and 7, okay? And so that means that we're including, it has to be 5, 6, and 7 when we're looking at those. So again, we could do them individually, or we can look at the overall thing. So we have to include 5, 6, and 7. So it may be easier, since it's just a few things, is to go through and do the PDF of 5, the PDF of 6, and the PDF of 7, and add them together for those. to get the pieces that you have. Just write those things down, and you will come out with the correct answer for those. Okay, and that's what I would recommend there. Now, if we had a really big number, I would probably do some subtraction, but I don't think you're going to have that. You're going to have some smaller numbers there for those. And so I would recommend just adding those pieces together using the first one for those. Okay? All right. So here, the rest of these kind of examples deal with using different methods. I would use the calculator each time. They should give us the same answer. But here, they have a table in the back that you could go and access, and you would just match up the pieces for them. And so we would see that here we had a 65%, X is 10. So we have all of these things on those. And so, but I would use the calculator on those pieces. And so they again do all of those different types there with those. Okay. Stat crunch as well, calculator. So again, I would use the calculator each time for these. All right, so how about the mean and standard deviation? Now these are going to be formulas. You've got to know these formulas to do these. And so they are straightforward. The mean is n times the probability of success. The standard deviation is the square root of n times p times 1 minus p. Okay, so here we have our 72%. We did 300 households for those. So we would expect our mean to be 300 times 0.72, so 216. And then our standard deviation, we would plug those things in, and we would expect it to be 7.8. Okay. All right, graphing those things. So here, if we graphed our probability distribution, 10 with a probability of 2, we could create our table and then plot those points. And you would see here that we have a right tail on those. Okay. Then if we changed our p, you would see here that here's our probability distribution, and it looks very bell-shaped. And then finally, we change our p again, and so here, this one looks like it has a left tail, so skewed left on those, all right? So here are just kind of some things looking at those pieces when we do those. So as p plays a role in our shape, and so does n, and all of those things with those. And what we actually see here is that if p is set and the number of trials increases, so as n increases, we're going to get more bell-shaped. And so as a rule of thumb, n times p times 1 minus p, if that's greater than or equal to 10, then it's going to be approximately bell-shaped, and that's going to give us some information as we move forward. Okay? And so we can see here with those, if we wanted to look if something is unusual, we could also go back and look at our standard deviation. Being more than 2 standard deviations away from the mean lets us know whether it's unusual or not. Well, 216 is between those 2 standard deviations, so it is not unusual. All right, well, those are the things that you're going to need here for 6.2.